Hey guys, welcome back to Kodevy and welcome back to yet another episode of the complete full stack series we are working on. So, in the last few episodes, we laid the groundwork and today we are going to take the real architectural step. So, everyone talks about microservice, but the moment you build it, you get stuck. How should I structure it? Logging, security, infra, CI CD, Swagger, versioning, health checks, and so many things. Most YouTube tutorials just create a controller and call it a microservice, but that's not how real system work in real time. Today we are going to scaffold a complete production ready microservice from the scratch, but we are not reinventing the wheel. We are not repeating ourselves, so we are actually conserving both the concepts, that is dry and reinvent the wheel. So over a year of period of time, I spent my complete time in researching and knowing about stuff, that how should a .NET microservice should look like, how should I structure it, what sort of architecture I should use there, and based on that I have developed a template that is what I'm calling as Kodevy template. So we will not be reinventing the wheel here. We will be scaffolding the microservice, but from the Kodevy template in no time. So without any further ado, let's get into it.
रुको रुको गाइस, चैनल को सब्सक्राइब करके जाओ। आपको ये वीडियो देखनी है वॉइस ऑफ कोड में। चैनल को सब्सक्राइब, लाइक करो, शेयर करो और अब मिलता हूँ मैं आपको नेक्स्ट वीडियो में। बाय बाय।
So before scaffolding anything, we have to understand what a microservice is. Since if you don't understand this template won't make sense. So imagine you are building an e-commerce system. There are so many modules, orders, notifications, payments, and all in just one single system and just single code base. This is what we call a monolithic architecture. And honestly, there's nothing wrong about the monolithic architecture. It's just that once the system grows bigger and bigger in future, it gets really hard to scale and less availability. So these are the challenges we face in monolithic architecture. High availability and high scalability are the two concerns we always require for services. The problem with monolithic architecture is that they are tightly coupled with each other. They all share the single code base. They all share the single database. That's why they are hard to scale. And one bug in a particular module, and your whole system is down in the production. And as soon as your code gets bigger, you will add more modules in future. You will add more features. So it will be a maintainability issue for your code base and system. Since your code base will be larger, it will be really hard to debug the code itself as a system. So here come the microservice uh, as a solution. So the microservice is basically a single responsible unit that is independently scalable and deployable. So let's say instead of just one big system, we can have user service, product service, order service, payment service as a separate microservice that are independent on their own, and most importantly, they share their own database. They don't share their data with other modules. They have their own database, and only they can access that data, or maybe they can allow others to access the data, but without them, other modules cannot access their data. So what are microservices? So microservice is basically a single business capability, or we can say in object-oriented programming, we always know about the solid principle which says single responsibility. So for any microservice to be a microservice, or basically for any module to be a microservice, first it should always follow this a single business capability, or we can say single responsibility rule, where it should be clearly focusing on one specific feature, domain, or maybe some area of work. Microservice should be an independent unit so that we can deploy it without touching other units in the system itself. Microservice manages and owns its own database without sharing the data with others. And all the microservices, since now they are not tightly coupled, they cannot talk directly, they cannot communicate directly. So they always communicate over a standard preset protocols like HTTP, REST, we have gRPC, then we have message event system as well. So this is how microservices talk with each other and get structured. Microservice is not basically multiple folders or multiple projects. It's not organizing your project structure. It's not some random copy paste GitHub code. It's basically clear responsibility, separate isolation, and an independent unit. This is what we can truly define as a microservice. See, each and everything has its own pros and cons, and so do microservices have. So microservices have their key benefit as they are independent to scale, since they don't rely directly on other modules, and deployments gets faster since now we have to just deploy a module, and previously in monolithic architecture we have to deploy the complete system as a whole, even if you are just changing in a single module or maybe a specific module. Since microservices are not directly communicating with each other, they don't need now a single framework. So if I am just building a microservice in .NET, now I don't have the pressure to develop other microservice in .NET itself, since they now are communicating via HTTP REST protocols or gRPC protocols, and all these protocols are not framework agnostic. So either of the microservice can be in any of the framework. So we have diversity of technology here. We can develop any microservice in any technology we want. And team members can work on different microservices, so leading less conflicts in Git and also in the work itself. Then we also have cons as well. So these are the architectural trade-offs of any microservice. Complexity increases since now we have to first thoroughly distribute the system into specific module. Sometimes it may be possible that someone overestimated a module, or maybe someone underestimated a module, and that can lead to architectural issues later on. Data management right now in monolithic architecture, all the microservices or all the modules actually are sharing just one single database. But in case of microservices, they have their own database. They are not sharing their data with others. So we have to make sure that cap theorem specifically from system design, that means consistency, availability, should be there at least, so that if any module demands a specific data to be present in other microservice, so we can easily replicate that. Then testing challenges. So if a microservice needs to be tested and it depends on another microservice, we have to mock the other microservice so that we can independently test the first microservice. And obviously, if as a system we have 4 modules, then we have to deploy 4 microservice as a single unit. That means requiring more infra, then requiring more sort of scaling platforms and all, monitoring them, logging and debugging around each and every microservice. So yeah, this is also an overhead in this microservice architecture. So we will be building a microservice here, but not from scratch. So Kodevy template will help us in this, and we will just do it in quick time without doing it from the scratch, without setting all the stuff. So introducing you the Kodevy microservice template. Here you go. So guys, in order to use this template provided by Kodevy, first we have to go to the NuGet official site, that is nuget.org. And in the home page itself, you can search for Kodevy.templates. And you'll be able to see 2 templates here. So we have to use the init one first. So let's click on this, and you can just go through this README. It contains all this things this template has. What about the project structure, the architecture, the packages, other packages. So we also have other packages here, and how to get started and all. So you can go through this README. So right now, when I'm recording this video, the latest version is 8.1.2. It may be possible that in future I update a new version, since I'm continuously updating and maintaining these templates. So please go through the README and please go through the releases section once I will just make this repository public. So let's copy it from here, try to install it, and we will just paste it here, and we will remove this 8.1.2. So what it will do, it will automatically install the latest version that is available in NuGet. Let's hit enter. So actually this template was already installed in my system. So it first successfully uninstalled it and then installed it. So you can check the success from here. This is the template name, the short name, and the language and tags. Now we have the template installed. This is just a one-time setup. We don't have to do it each and every time. We have to just run a command here. So right now I am in this directory, and this is where I want my first microservice to be in. So we are using this init template. Actually, we'll be creating so many microservices in this complete episode, but our goal is to have a single repository, mono repository for each and every microservice. That means they will be independent, they will be scalable, they will be deployed independently, they will have their own database. But on a structural point of view, if we talk about how do we managing them in the Git itself, So we are having a single mono repository for all the microservices, and the init template is what is providing us that particular thing. So we have installed that. Let's see how it works out. .NET new, we have to type the microservice, oh sorry, the template name. This is the short name of the template, Kodevy microservice init. Then we will just type the organization. So right now I'm considering as Kodevy. Then we have to write the system name. So system, let's say I'm developing the core system, and we have to also tell our the first microservice name. So let's say I'm uh, thinking of creating the first microservice as identity, and this argument is optional. So if you provide a name here, this is actually a folder name. So if I provide a name here, so let's say first microservice, or basically first monorepo, you can say, as this will be going to a monorepo. So it will create a new folder inside this directory itself. But right now I don't want that. I do have a specific directory for this. So I will remove this optional argument, and it's not mandatory. So let's hit enter. And as you can see, the template Kodevy microservice solution was created successfully. And also we can verify it from here. So inside this particular directory, we got the first file as directory.build.props, nuget.config, readme.md, and services. So we will talk about each and everything. What is there in the services, what is there in each of the files. But this is how with just, I think, 2 or 3 commands, we have successfully created a monorepo, and that along with the first microservice. And we will see what are the structure, what is the code there, and how the code is working, and we will actually run it, and we'll see what are all the things that is being provided by the Kodevy platform as the scaffolding of the first microservice. So now let's talk about this directory structure, whatever this template has given to us. So we have the directory.build.props file. Specifically, it holds all the versions of the packages all the microservices are going to use. Then we have the configuration file for NuGet. We don't have to go in depth for this file. Then we have a readme.md, which we can read. So let's open it with some, okay, let's do it with cursor itself. It says that this is a .NET 8 monorepo microservice solution, and we are using clean architecture here. So with Kodevy platform packages. So we have other packages as well in the Kodevy platform in NuGet, and this template is actually utilizing those packages. Project structure. So this is how the project structure is going to be look like. We do have nuget.config. We have already verified that. We have directory.build.props, and then we have a services folder. So inside this services, we will be having each and every microservice. Each microservice is following clean architecture with 4 layers. So we have API layer, application layer, domain layer, and infrastructure layer. I'll go in detail for each and every one. And also each and every microservice, as I have told you, is utilizing some platform packages from Kodevy platform itself. So we do have an API platform, we do have application, domain, and infra platform. So these all are 4 packages which internally each and every microservice is utilizing from this template. And these are configured in nuget.config. So these are automatically referenced in each and every project. We don't have to do it manually. Okay, so this is actually about the instruction on how to run the services itself, and what about database migrations and all. So we'll talk it about this later on. Let's see first what we got inside the services folder. Okay, so inside the services, we have the organization, system, and microservice. So this is how the naming convention will look like here: organization, system, and microservice. And inside this microservice, this is the first microservice identity. We have 2 scripts. One is the PowerShell, and one is the shell script. We have just one Docker file, one solution, again the NuGet config, readme.md, and src folder. And inside src, we have all the 4 layers. So let's open this solution with Rider, and let's see what we got. So as soon as we open this solution in JetBrains Rider, it lands us on the readme.md page, but it's again like we need to go through it later on. You guys can go through it once. So let's first talk about the structure this template provides us. So we do have 4 layers as discussed or listed in the README section. We do have API, application, domain, and infrastructure layer. So if I talk about API layer, so we do have controllers, we do have extensions, services wire for dependency injections, then all the application settings here. Some authorization policies and program.cs finally are entry point. So this is the API layer where controller will decide and will talk to the client itself. Then we have the application layer. So this is the second layer of the system itself, and we are following a clean architecture here. In this layer, we have API clients, some configurations, contracts, and DTOs, mappers, and some services. So these services will be utilized by the controller layer, and then we have the domain layer. This is the core of the application, and this is the only layer that doesn't depend on any sort of external layer. So this is the root layer of our system, and it doesn't have any sort of outgoing dependencies. Entity here doesn't depend on anyone. This is just a complete independent unit on itself. It doesn't depend on anyone. Then we have the infrastructure layer. So it deals with repositories and persistence, that how data will be persisted and what will be the rules and logics for persisting the data, or basically retrieving the data from the system itself. So this complete structure makes a single microservice, and this is all achievable by just one microservice template. You can use Kodevy for that. You just have to do one thing. Initially, when we will do the setup, you will face some issues. So you just go to this file, authorizationpolicies.cs, and just comment out these things from here. So if you just uncomment them, you will face issues. Just comment out these from here and you are good to go. So this is what we got. And if you talk about let's say if I go to each and every CS project of every layer, so we do have API, application, domain. You can see we have a reference to Kodevy platform packages. So API layer is actually referencing to kodevy.platform.api. The application layer is referencing to application, and vice versa. Each and every layer will actually referencing the respective layers from Kodevy platform. And now you might be wondering, what is this? So let's talk about the infra first. See, we have this infra, and you can find it in the NuGet page. So we have all the 4 layers here, all the 4 packages. Right now we are using 3.0.1. So this is nothing. So this is just let's come here again and let's search Kodevy.platform. So these are all the 4 platform related packages which I have developed and published to NuGet. These also are public packages, but they are not specifically used by us. They are actually internally used by our microservice template. So whenever we scaffolds our microservice, these packages are internally used by the microservice itself. The domain, infra, API, these all packages provide the base level utilities for our microservice. So we don't have to do much sort of coding. So we don't have to do or basically we don't have to write all the code there, which is actually repeatable, and it's kind of a utility code. So if I talk about program.cs, this is just a minor, or we can say a minimal program.cs. But everything here, if I talk about configure middleware, inside this you can see use global exceptional handler. Then we have use authentication, authorization. So all the utility code, that is, it has been provided by the platform packages and APIs. Let's say if I hit on this, not this, sorry. If I go like, okay, we'll not find it here. Let's talk about the web application itself. So we have the configure app. We go to this extension function. And as you can see, we have this is the add base authentication authorization. Then we have Swagger configuration. Let's click on this. So it will say it's going to the external sources. That means the decompiled version of it. See, you can see here, this is actually decompiled with JetBrains decompiler. That means it's not a complete raw code here. It's basically a byte code. We cannot just edit this code. And this is basically powered by kodevy.platform.api, and then we have the services via a class there, or maybe a namespace. This is the complete functionality that has been provided by the platform packages, and we do have specific functionalities for each and every layer that has been packed and shipped into the Kodevy platform packages. So think of these like as a utility file which which we don't need to write each and every time we scaffold a new microservice. So let's try to run this application. And in order to run this application, first let me show you. So we have this app.json. Let's talk about the development. And we have, this is basically a complete template that is database agnostic. So we can change the database here by just mentioning the provider. And right now, the template supports only two providers, PostgreSQL and MS SQL. So we will be using PostgreSQL for this complete series. And for that, we have to set up the database here. So before that, we have to do something. So PostgreSQL will be running on our own local Docker instance, and we have to set that. So come here, and within this hierarchy, beside of the src, we have to create a new folder. We can just name it as db init, and we can just add a simple script there, and we can add a simple script there. So let's create a file that's named as 01 create databases, create database.sql. So this will be a .sql file. So this is the content. In this, actually, we are just creating a SQL file. So we don't have to make the database again and again. Like every time we are just migrating, or maybe we just lost our data in the Docker itself, maybe we just uninstall the Docker, we completely remove each and everything from Docker. We don't need to create the database again and again. So this is the script we will be requiring in each and every phase when we'll clean up our Docker as well. So it says like you can just change it up, create database, your database name, whatever you prefer, you can have it. Then you have to make a user for this specific microservice. So this is for identity microservice, we are creating a new database, new user with this password. Then we are just providing this user the complete ownership of that database and revoking all access on this database from public. So we have publics, that means from outside, and then granting all privileges on database to this particular user which we have just created, and granting all on this schema public to this particular user. So we have a public schema and we are granting all the permissions to this user on this public schema. So this is the first file we have to create, and then we have to add one new file here that will be a Docker file. So we'll be adding a compose.yaml here, compose.yaml, and we have this content here. So you can just copy paste it. I will let you know what this is. We are just using version 3.90, then services Postgre, image Postgre 16, container name Postgre local, environment Postgre user is Postgre password is Postgre, ports is 5432, volume, and then this volume section, this is important. So we are just telling Postgre that this is our script in this folder db init, and you have to get in there and execute this script so that you can create a volume for us inside which our database will be there in the Docker instance. Okay, this is done. Now we have to go to the solution. So let's go to the development.json. For Docker instance, the host should be localhost. Port is this 5432. Database is code by core identity. Okay, let's cross check the database name. So spread it right. So this is the database code by core 3 identity. We have to point it here. Then we have the username. So we have this username here, and the password we also need to copy from here. So the password, okay, this is not the user, this is the password. This is actually the user. So password, right? Okay, this is how our database is going to be set up using Docker, and that's it. So come back to terminal. So we do have our file here, compose.yaml. So what we will do, we'll run this command from here. So it says docker compose f, and then we have the file name compose.yaml up, and this D is basically to run it in the background. Let's set it up, and it says not connect to the Docker daemon at Unix, this particular place. This means if it's actually warning us that your Docker is not running. So first we have to run the Docker engine, and as a prerequisite for this session, Docker is required there. Okay, now the engine is running. I can just leave it as it is. It should be running here. Docker desktop is running. Now I can just run the same command. Allow, it will just pull the Postgre 16 image to run it in its own container. So let's wait for it. Okay, let me access some sort of data from here. Okay, it has created the network. The volume also has been created, and I think the database should be set up and running. How? Due to this particular script. So we have just provided this script here. So Docker, I think, has created our database here. And if we want to check, we can actually test it from the by running the application, and also from the Postgre instance from here itself. So let's try to connect with it source manually. Next, host is localhost, port is 5432, 5432. I'm using an inbuilt database inspector in JetBrains Writer, and the instance is no completion. This is actually a PostgreSQL. So PostgreSQL, localhost, and 5432. So proceed. User, we can have it from the appsetting.json. So this is the user, and the password is the same. Just there is not user. Wait a second. I need to copy it. This is the password. Say forever. Test this connection. See, test connection succeeded. That means that compose.yaml has created our own database along with a user, a password, and provided all the privileges to that particular user. So we can connect to this database, and we are here. So we have this Postgre, then we have this public schema, and right now we don't have anything here. Okay, that means we are ready to make this service up and running. This is the first microservice that we just scaffold using the init template. So let's quickly try to build it and then run it. So first we will build it, and let's see if we got any sort of error. Okay, the build has been succeeded without any issues. So let's quickly run it. Got it. So we got our first microservice that has Swagger. So we have code by code.identity dev version 1. And this application is not secured by any sort of authentication. Okay, let me just zoom it. And we have a single API, which I think we can use for now. So let's try it out. Let's send the data from here. Don't send the ID. The name, let's say Vijay. So this is the email. So you can say developer.javalogist@gmail.com. The name is Vijay Singh Rana, and leave all other stuff as it is and try to execute it. Okay, something is wrong right now. I don't know what is wrong. Okay, so an error occurred while saving the entity changes. See the an exception for details. So it says that relation user does not exist, and it's not an issue actually. We are trying to save some data to the users table, but right now user does not exist, and that is because we have freshly created the database. We didn't create any sort of table there. That's the reason user table does not exist, and the backend is not able to create a new user and save it in the Postgre. But most of the important thing, our service, microservice, is up and running in the local host, and we can see the Swagger UI itself. So, as you have seen that how we have just within just 2 commands scaffold our first microservice, and also we were able to successfully compile and run the microservice along with our database connection. So that's why my Kodevy microservice template is here, and the reason for why Kodevy, why this particular template. See, it's basically an opinionated but yeah, practical architecture. We do have clean separation of concern. We have 4 specific layers, and we are working on clean architecture. It's designed for scalability. We can easily scale it up, and we will see later on in the next episodes how we can scale it up using Docker. It has been built with real world enterprise thinking. So I was working on so many projects at that time when I was developing this. So I got a collective knowledge on stuff, and then I collect them, basically group them together, and this is the result of that. And in this I try to be specific, and so that I didn't achieve some sort of complexity later on. And yeah, maybe to some extent there would be some sort of complexity, but I have tried my best. What this templates give you, so as we have seen, there's a layered architecture. We have structured dependency flow. I will tell you in the next episode when we will go more in detail. It has production ready configuration. We do have logging and error handling. You can see the logs in the console as well when you will run in the local host, and it's really ready to scale and extend. We can scale it, we can scale it horizontally, vertically, and we can extend the functionality for a single microservice. So guys, this was it. I hope you liked this episode. I know it's a bit of complex episode. There are so many things to just grab for the first time, but no worries. If you guys have any sort of doubt, if you get stuck somewhere, you can put your queries in the comment section, and I'll be really happy to help you guys. Alongside, try to do the stuff which we have done here. Try to follow along. Try to set up things in your own system and follow along with this complete series. In the next episode, we'll be discussing more on this template and whatever the structure this template has provided us in terms of the microservice itself. We'll go more deeper into how this template and how the microservice is connecting to the Kodevy platform APIs, and what is there in the APIs itself, the utility classes and all. So we'll all see these in the next episodes. Till then, keep watching, keep learning, and subscribe to my YouTube channel, Voice of Code. And again, I'm saying, if you guys face any sort of issues, if you get stuck somewhere, feel free to leave your queries in the comment section, and definitely I'll be helping you by making maybe another videos on queries itself, or maybe providing some helpful suggestions on the next video.